morning everyone. You are watching Guru Brahma classes for JEE and NEET. We are in the chapter thermodynamics. And today in this session we are going to learn about enthalpy of combustion. Enthalpy of combustion. Already we know that for a particular reaction there will be some enthalpy associated. Okay. Already we have studied about enthalpy of a reaction, enthalpy of formation. So there are different types of enthalpies of reaction. One of the enthalpy of reaction is enthalpy of combustion. Already it is mentioning that it is combustion. Combustion means reacting with the oxygen, burning with the oxygen. So combustion reactions are all exothermic reactions. Exothermic reactions. So during combustion reactions are all exothermic reactions. Combustion reaction means combustion. Is that a combustion? Combustion reaction is always exothermic. Is that a exothermic? That means for combustion reaction always delta H will be negative. Delta H will be negative. Okay. So already it is mentioned that during a reaction there will be some change in the heat when reactants are converted into product. That change in the heat or change in the enthalpy is called as enthalpy of reaction. Enthalpy of a reaction. When that enthalpy of reaction satisfies the definition of enthalpy of combustion, then we say that enthalpy of reaction is also called as enthalpy of combustion. So all the combustion reactions are all exothermic reactions. They undergo combustion by releasing heat. They release heat. They release energy. As they release energy during the combustion process, delta H is negative. Okay. So let us see what is enthalpy of combustion. It is the quantity of heat evolved. So heat is released when 1 mole, always this is important, when 1 mole of substance burns or combusted, burns completely in excess of oxygen at a given temperature and at constant volume. Why we are mentioning that it is at constant volume? Generally enthalpy of combustion is calculated in calorimeter, bomb calorimeter. In bomb calorimeter, volume is constant. First of all, we will calculate the enthalpy at constant volume. Later, we convert into constant pressure. That is the reason why it is mentioned here it has constant volume, and that is called as heat of combustion. Right? So, when 1 mole of the substance burns, let us take a reaction. See, C graphite 1 mole plus O2 gives CO2. This is enthalpy of reaction. Can I call this enthalpy of reaction as enthalpy of combustion? Yes, I can call this enthalpy of reaction as enthalpy of combustion. Why? Because it is satisfying the condition, or it is satisfying the definition of enthalpy of combustion. What is enthalpy of combustion? It is the amount of heat energy released when 1 mole, here carbon, 1 mole of carbon in the form of graphite is combusted. That is the reason why enthalpy of reaction is equal to enthalpy of combustion. Right? In the same way, let me combust carbon monoxide, CO plus half O2 gives CO2. Here carbon monoxide is completely combusted. And how many moles of carbon monoxide is combusted? 1 mole. So there will be enthalpy of the reaction. This enthalpy of the reaction, I can call it as enthalpy of combustion. Why I am calling it as enthalpy of combustion? Because this reaction is satisfying the definition of enthalpy of combustion. In the same way, let us take CH4 plus O2 gives CO2 plus H2O. Balance this equation, 1 carbon, 1 carbon, hydrogens 4 left side, hydrogens 4 on the right side, multiplying with 2. 2 oxygens, 2 oxygens, 4 oxygens on the product side, so 2. So now this is balanced equation. In this reaction, for this reaction, there will be some enthalpy of reaction. That enthalpy of reaction is represented by delta RH. Okay, can I call this enthalpy of reaction as enthalpy of combustion? Yes. Why I am calling? Because this is satisfying the condition, or it is satisfying the definition of enthalpy of combustion. Right? So in this way, for example, let me take another example. C2H6 plus O2 gives CO2 plus H2O. When hydrocarbon is combusted, always carbon dioxide and water are the products formed. Now C2H6 is what? Ethane. Ethane is completely combusted, so that carbon dioxide and water are formed. Now balance this, right? 2 carbons. If I take 2 moles here, for example, 4 carbons, 12, 6 to 12, 4 to 8 plus 6, 14, 14, 7 O2. Now, can I call this enthalpy of reaction as enthalpy of combustion? No. Why? Here 2 moles of substance is combusted. From the definition, we have studied that when 1 mole of the substance is completely combusted, then what amount energy released is called as enthalpy of combustion. Now, in this, the enthalpy of reaction cannot be equal to enthalpy of combustion. Not equal, because 2 moles. Then what will be the relation between enthalpy of reaction and enthalpy of combustion now? Enthalpy of reaction is equal to 2 into enthalpy of combustion. Right? Or enthalpy of combustion is equal to half of enthalpy of reaction. So this will be the relation. So always when you are calculating or studying regarding the enthalpy of combustion, we have to see that only 1 mole of the substance is combusted. Okay. So the quantity of heat evolved when 1 mole of substance burns completely. You have to see that completely it has to burn. Right? Again, now the question arises here like this. C graphite plus half O2 gives rise to CO. This is enthalpy of reaction. Can this be enthalpy of combustion? No. It cannot be enthalpy of combustion. Why? Because this carbon is not completely combusted. If this carbon is completely combusted, what will be the product? The product formed will be carbon dioxide. Now here you can see the product formed will be carbon dioxide. Understood? So the substance must be completely combusted, and that substance must be 1 mole of the substance. Then that is called as a enthalpy of a combustion. The heat of combustion is always negative because the combustion process is always exothermic. The heat of combustion of graphite, specific value, standard calculated value is given 393.5 kilojoule per mole. The thermochemical equation for the combustion of 1 mole of graphite, here it is given. See, graphite in solid state combusting with oxygen, carbon dioxide is formed. When carbon dioxide is formed, we understand that it is undergoing complete combustion. 393.5 kilojoules of energy is released, right? Standard enthalpy of combustion. What is standard enthalpy of combustion? The enthalpy change, the change in the heat per mole or per unit amount of the substance when it undergoes combustion, and all the reactants and products, here you see reactants and products must be in their standard state. Already we have studied what is meant by standard state. Standard state, most stable state. Standard state means most stable state is called as a standard state. So when the reactants and products are in their standard states, that is most stable states, in that situation we call it as standard enthalpy of combustion. When we are calling it as standard enthalpy of combustion, when the reactants and products are in their standard state. What is meant by standard state? Most stable state. Okay. So that is about enthalpy of combustion. Next we shall see some PYQ of JEE main regarding enthalpy of combustion. So let us see. So question is given in 2022. At 25 degrees centigrade and 1 atmospheric pressure, the enthalpy of combustion of benzene and acetylene are minus 3268 kilojoule per mole and minus 1300 kilojoule per mole respectively. The change in enthalpy of reaction is asked. Enthalpy of combustions are given. So let us solve in two ways. First of all, take reaction 1, enthalpy of combustion of benzene. Benzene is combusted, C6H6. When it is combusted, what are the products formed when hydrocarbon is combusted? Carbon dioxide and water are formed. 6CO2, 3H2O, 12 plus 3, 15 oxygens. So 15 by 2. Okay, so this is enthalpy of combustion. Let me take it as 1. Then that is given as right, minus 3268 kilojoule per mole. Right? And reaction 2. So first of all, we should be able to write the equation for combustion. Here what is undergoing combustion? Benzene is undergoing combustion. And acetylene is also undergoing combustion. What is the formula of acetylene? C2H2 plus O2 gives 2CO2 plus H2O. Oxygens 4, 1, 5 on the reactant side. So I can write 5 by 2. Delta H2 is equal to minus 1300 kilojoule per, right? So these two are given, and we are asked one enthalpy of reaction for, let me take it as the required one is 3C2H2 gives C6H6. Enthalpy of reaction is asked. This is asked. Let me take it as 3. How can we solve it? We can solve, see, from these two equations, we want this equation. How can you get it? In the required, C2H2 is present on the left side. In the given, C2H2 is present on the left side. Okay. But in the required, there are 3 moles. Here there is only 1 mole. So equation 4 can be obtained by multiplying equation 2 with 3 into equation 2 plus, see, in the required equation benzene is on the right side, but in the given benzene is present on the left side. So you have to reverse. So reverse equation what? 1. So then what do you get? Delta enthalpy of reaction 3 is equal to 3 into enthalpy of combustion 2 plus reversing minus enthalpy 1. And what do you get? 3 into minus 1300 kilojoule plus minus 3268 kilojoule. So then what do you get? Minus 3900 minus, that is plus how much? 3268. What do you get? Minus 632 kilojoule. So what is the answer? Third option is the answer. So this is one way of solving this question. Let us see the other way. Okay. So enthalpy of reaction is asked. What is asked? Enthalpy of reaction. When enthalpy of combustion are given, when enthalpy of reaction is asked, enthalpy of reaction is equal to sum of the enthalpies of combustion of reactants minus sum of the enthalpy of combustion of products. Reactants minus products. So enthalpy of reactant. What is reactant? Acetylene is reactant. So how many moles are there? 3 moles. So 3 into, what is the enthalpy of C2H2 given? Enthalpy of combustion of C2H2 given minus 1300. Okay, minus of. Then what is the enthalpy of combustion of benzene given? 3268. So minus 3268, right? So then what do you get? Minus 3900 minus plus 3268. Then what you are getting? Minus 632 kilojoule. So either the way you can, if you remember the formula, you can directly solve. If you don't remember the formula, this is the actual procedure. Okay, let us go with the next question. So when is this asked? This is asked in 2022. Okay, what is the question? Carbon in the form of solid and combustion gives you carbon dioxide releasing 400 kilojoule. When carbon dioxide is formed, 400 kilojoule heat energy is released. The same solid state of carbon, when it is combusted, it is releasing carbon monoxide. Okay, it is producing carbon monoxide, releasing how much amount of energy? 100 kilojoules. When carbon monoxide is formed, 100 kilojoules of energy is released. So now what is taken? Coal is taken. When coal of purity 60%, coal of purity 60% is allowed to burn in the presence of insufficient oxygen. 60% of carbon is converted into carbon monoxide. So 60% is converted into carbon monoxide. Whereas and the remaining is converted into carbon dioxide. That means 40% of the carbon is converted into carbon dioxide. The heat generated when 0.6 kg of coal is burnt. Here taken is coal. Okay. So how much is taken? Initially 0.6 kg. That is equal to coal. How much taken? 0.6 kg. That is equal to 0.6 into 10 power 3 grams, which is equal to 600 grams. Originally, coal taken was 600 grams. In that 600 grams, only purity is 60%. So pure coal will be 600 grams. Among that 600 grams, 60 percentage is pure. 60 percentage means 60 by 100. Then what do you get? 360 grams. Okay, 360 grams. So though 600 grams of coal is taken, among that only pure coal, the remaining is impurity. The pure coal is only 360 grams. The remaining is impurity. And among that 360 grams, 60 percentage of carbon. So coal means carbon. 60 percentage of carbon is converted into carbon monoxide. So 60 percentage of 360. Okay. 60 percentage of 360 grams is equal to 360 into 60 by 100. That is equal to 36 into 6. 36, 216 grams. So 216 grams is converted, this carbon is converted to carbon monoxide. See, converted to carbon monoxide. The remaining 40 percentage of 360 grams is equal to, what will be 40 percentage of 360 grams? Okay, 360 into 40 by 100. So 36 into 4, right? 6 4s 24, 144 grams. So this 144 grams carbon is converted into carbon dioxide. Okay. So this is what? Coal initially taken 0.6 gram kg, that is equal to 600 grams. Among that 600 grams, he is saying that only 60 percentage of the coal is pure. So how much pure coal we have? 360, and among the 360 grams, 60 percentage is converted into carbon monoxide and 40 percentage is converted into carbon dioxide. Okay, now let us see the reactions. Coming to the reactions, C solid plus O2 gives CO2 plus 400 kilojoules. What does that mean? When 12 grams is combusted, how much is produced? How much energy? 12 grams of carbon, 12 grams of coal on combustion produces 400 kilojoules in this reaction, from this reaction. So how much carbon is converted into carbon dioxide actually? Here given, see, 144 grams of coal produces, let it take X kilojoule per mole. What will be X? How do we calculate X? Right? How do you calculate X? X is equal to 144 into 400 by 12. Right? 12 12s 144. 12 into 400. 12 4 48. 4800 kilojoule per mole. So from this first equation, we have calculated that 4800 kilojoule per mole is released. From the next equation, let us take what is that? C plus half O2 gives CO plus 100 kilojoule. What does that mean? That means that 12 grams, again from stoichiometric equation, 12 grams of coal here from this equation produces how much? 100 kilojoule when it is converted into carbon monoxide. When it is converted into carbon monoxide, it is producing 100 kilojoules. But how much coal is converted into carbon monoxide? 216 grams. Okay, 216. So 216 grams of coal produces Y kilojoules. Let us calculate Y. Y is equal to 216 into 100 by 12. Okay, it is equal to 12 ones 12, 12 eights 96. That is equal to 1800 kilojoules. So totally, how much energy is released? Total energy released. Total energy released is equal to X plus Y. How much X? 4800 kilojoules plus Y 1800 kilojoules. That is equal to 6600 kilojoules. So 6600 kilojoules of energy is released. So here answer. Understood. Next, let us see the next question. Question asked in 2021. Okay. 2020. An average person needs 10,000 kilojoules energy per day. The amount of glucose, molar mass 180 grams per mole, needed to meet this energy requirement. So an average person per day, how much energy does he need? He needs 10,000 kilojoules energy. Okay, here you are given enthalpy of combustion of glucose. Enthalpy of combustion is always calculated per mole. That means 1 mole of glucose on combustion. What is that? On combustion produces or releases. What is that? Releases how much energy? Releases 2700 kilojoules. 1 mole. 1 mole of glucose weighs how much? 180 grams. So 180 grams of glucose on combustion releases how much? 2700 kilojoule per. The question asked is to per 1 day a person is requiring how much energy? 10,000 kilojoules. So to release 10,000 kilojoules, X grams of glucose on combustion releases 10,000 kilojoules. Cross multiply this. So X is equal to 180 into 10,000 by 2700. Right? 180 grams of glucose produces 2700 kilojoules. Per day, how much energy is required for an average person? 10,000 kilojoules. So, how many grams of glucose is producing 10,000? The amount of glucose is asked. Is it the amount of glucose needed to meet this energy requirement for a person to meet this 10,000 kilojoules of energy per day? How much glucose has to be burnt in his body? Okay, so then that will be equal to, then what will be the answer? 666.6, right? These many grams is required. So nearest integer will be 667 grams. Answer will be 667. Okay, let us see the next question. Question asked is in 2021. Similar type of question. The standard molar enthalpy change for combustion of graphite powder is. So standard molar enthalpy of graphite is given. How much given? Minus 2.48 into 10 power 2 kilojoule per mole. If you write it in the form of equation, then what you write? C graphite plus O2 gives CO2. Enthalpy of combustion is equal to minus 2.48 into 10 power 2 kilojoule per mole. In this way we write. What does this mean? This means that 1 mole of the substance on 1 mole of the graphite powder on combustion gives this much amount of energy. The same answer. The amount of heat energy generated at combustion of 1 gram of graphite powder. So 12 grams graphite on combustion produces or releases how much energy? 2.48 into 10 power 2 kilojoules. You are asked when 1 gram graphite on combustion releases X, let us take. Okay. Then X is equal to 248 by 12. So 12 20s 240, 12 6 72 66. Okay, kilojoules. Nearest integer is asked. Nearest integer, that is equal to 21 kilojoules. Okay, so 21. Let us see the next question. So combustion of 1 mole of benzene is expressed at. So this is how combustion of 1 mole of benzene is expressed. Right? Enthalpy of formations are given. What are given? Enthalpy of formation of benzene C6H6 is given as how much? 48.5 kilojoule per mole from 1.16, this one from 2. So what is given? Standard enthalpy of formation of what is given? Formation of CO2 is given. So CO2 is given as how much? Minus 393.5 kilojoule per mole. Okay. Next, third, what is given? Standard enthalpy of formation of water. Enthalpy of formation of water is given. Standard, these are all standard enthalpies. So that is equal to how much? Minus 286 kilojoule per mole. Okay. So these three are given from point 1, 2, 3 given. Then what is asked? What is asked is enthalpy of combustion of benzene is given and standard enthalpy of combustion of 2 moles of benzene is asked. 2 moles of benzene, right? So when enthalpy of formations are given and when enthalpy of reaction is asked, for which reaction? For this reaction. So what is this? C6H6 plus 15 by 2 O2 gives rise to 6 CO2 plus 3 H2. So this is the reaction. For this, what is asked? Enthalpy of reaction. Enthalpy of reaction. Okay. Enthalpy of reaction is how much? So when enthalpy of formation is given and when enthalpy of reaction is asked, we have a formula that enthalpy of reaction is equal to sum of the enthalpy of formation of products minus sum of the enthalpy of formation of reactants. Okay. So products, what are the products? Carbon dioxide and water are products. Then what you can write? 6 into enthalpy of formation of carbon dioxide plus 3 into enthalpy of formation of water minus enthalpy of formation of C6H6 plus 15 by 2 into enthalpy of formation of O2, right? So this is how we need to calculate. So which is equal to 6 into enthalpy of formation of carbon dioxide, how much given? Carbon dioxide is given as minus 393.5 plus 3 into enthalpy of water is minus 286 kilojoule per mole. Okay, minus of enthalpy of benzene given 45, right? 48.5 kilojoule per mole plus enthalpy of formation of element in its standard state is equal to 0. 15 by 2 into 0. Okay. What is that? Enthalpy of formation of element. Enthalpy of formation of an element in its standard state is always taken as 0, always considered to be 0. Then on calculating this, what you get is so what is that? 6 into 6 5s 30, 18, 21, so 393.5 into 6, 30, 18, 21, okay, 54 to 56, 6 3 is 18, 18 plus 5, 23. So minus 2361 plus here 286 into 3, 18, 83 is 24, 25, 6 to 8, 858 minus 858, okay, minus of 485, right? Then calculate it. Minus 2361 minus 858, right? Is that given minus or plus? Enthalpy of formation is plus, right? Then what do you get? 48.5. So 48.5, 5, 17, 16, 12. So what do you get? Minus 3267.5 kilojoule per mole. Okay, kilojoule per mole. So what did we get? Per how many moles did we get per 1 mole? But the question asked is standard enthalpy of combustion for 2 moles. So this is for 1 mole. For 1 mole. For 2 moles, minus 3267.5 into 2. That is for 2 moles. Then what do you get? 5 to 10, 2 7s 14, 115, 12, 113, 415, 236, 6535 kilojoule per mole. Okay, 6535 kilojoule per mole minus. So it is asked in the form of what? It is asked in the form of minus x. So you are finding minus x. So what is x? So this is minus x. Then what will be x? 6535 kilojoule per, okay, kilojoules. That's it. Kilojoules. So these are the different types of questions asked in JEE mains, previous JEE mains questions on enthalpy of combustion. In the next session, we shall discuss other type of enthalpy of combustions. We shall meet in the next lecture. Thank you for watching.